Hello everyone, this is Amir from Audio Science Review. You all asked for more debunking videos. Sorry, here's another one. It's this whole category of USB filters and what are fondly called decrapifiers. I think that's an industry term these days. It makes sense, right? You think computer, USB port hooked up to a DAC, computer's busy doing a ton of things, which it is, and that it surely must generate noise that then finds itself into a DAC and pollutes the output of the DAC. You could say it adds noise, it adds jitter, takes away detail, and what have you. So manufacturers know this, and for the last, I don't know, 7 or 8 years, they've been building these filters. I think one of the earliest ones was this AudioQuest JitterBug. Very, very catchy name, very clever marketing. You can see I was an early adopter buying mine back in 2015. I'll buy them so you don't have to. I'm fascinated that they sell multi-packs of this. You can buy 1 or 3 or 5, and I believe they advertise you should use more than one, and that you not only pass your DAC output through this, but you also plug it into the other USB ports you have on your computer and snuffs the noise out of them. Assuming they think that they're all shared ports on the same USB controller, which may be, but and I've seen people string a whole bunch of these things and different brands where they put like 5 or 6 of these things in series, and of course, every time they add one, the sound improves, so they add another one, add another one, add another one. So our challenge is to find out if these things improve the sound or not, and so let's dig into a review that I did of the JitterBug. It's actually the second time I'd reviewed it and measured it. This is what it looks like. If you go down here, you'll see that it says it reduces jitter and packet errors, resulting in distortion that causes flat and irritating sound. If you get packet errors, you will know it. It'll buzz, crackle. I mean, you basically have a chunk of kilobytes of data from your audio is just taken out. So the waveform will go like this, and then it'll be a chopped out section. It will not result in any of the things they're talking about. It won't sound flat, it just sounds awful. And in the short lengths that we use, USB cables for typical home use, this is absolutely not a problem. Once it becomes a problem, this won't fix it anyway. You'll need a repeater or some other method to extend the length of USB cable. And but anyway, the rest of it, if it results in distortion, we measure distortion. If it results in noise, we measure noise. If it results in jitter, we measure jitter. That's what we're here for. So how to test it? I took a topping D50S. One of the neat things about topping, for this case, is that it has a separate 9-volt adapter in there. So let me see if I can find it. Yeah. So sorry, a 9-volt connector, but it's really a USB plug. So they give you a little cable that goes from this power port to a USB that powers it, and you can either power it with your own phone charger, what have you. Then it's got a data port that you use to actually communicate with it. So we get to plug in and experiment with the JitterBug on both ports, see if it makes a difference on one or the other. Because there's a theory as to whether the data is noisy on USB or it's the data bus that's noisy, or both. So let's go back to our measurements. So here I plug it in series with the power port and measure the output of the DAC. Remember, that's the only thing we're interested in. None of us listen to a USB cable by sticking it in our ears. This USB is carrying digital data. We need to convert that to analog. And all we care about at the end of the day is what comes out of our DAC, not what goes in it. What goes in it is the designer's problem. So if we measure the D50S and take a wide spectrum of 1 kilohertz tones, so this is our desirable tones, and all this other stuff is unwanted, but they're very, very low level. And we compare it with topping by itself in red, and then topping with 50S with JitterBug plugged into it. And as you can see, the two graphs just land on top of each other. There is absolutely no reduction in noise. We had all this noise it could get rid of. We had all this distortion that it could get rid of, and it got rid of none of those. Let's connect it on a data bus and see what that does. And this time I'm zooming into just 20 kilohertz bandwidth. And again, stuff just lands on top of each other no matter how we plug it in. And so clearly, no distortion was taken away. You can see all these little bits of noise in here. Surely if it reduced any noise, those little ticks should have at least gone down. But no, even measuring down to minus 150 decibels and 160 decibels, it makes no difference. And another test I ran, which is just everything's plugged in the way it is, but I don't turn on a stream of audio to the DAC. So we're just looking at residual noise that's on the analog output of the DAC. And again, we tested with AudioQuest on, whether it's on power or whether it's on data. Notice that the background noise is the background noise. There is no difference whatsoever. So what is filtering eludes this testing at least. So someone may say, well, maybe it doesn't work on that DAC, maybe it works on another DAC. So I went one step lower at the time, topping D10, one of my favorites. I think it was like $60 DAC at the time. And surely this is a noisier, less performant DAC than the topping D50S, and see what we get there. So here we look at our usual dashboard now, instead of just a zoomed in spectrum. Remember this SINAD is our noise and distortion, and there are around 105 or so, depending on which channel you look at, 2.109 volts coming out of it. We plug in the JitterBug, and what do we see? Still 105, still 2.11 volts. No difference in the spectrum over here in FFT. We'll look up here, you see these 3 pulses, for example, and identical performance. I mean, it couldn't be more the same than it is. So it's absolutely not making a difference. I run the same FFT that I ran before, and well, there's little variation here. That's just happens. These things are random, noise being picked up and what have you. But JitterBug just doesn't do anything. If you look over here, it's just all identical. The 2 curves land on top of each other. But maybe none of the top DACs benefit from this. Let's switch brands to IFI IDSD DAC. It's a lower performing DAC yet again. Its SINAD is only down to 93 or 94 dB. And this is with it hooked up direct. We see the distortions sort of go from highest to lowest here. And we plug in JitterBug, what happens? Nothing. So, the exact same SINAD is still there. The output voltage is the same, all the same distortions. There's not a sign of anything happening in here. So you might say, well, maybe these DACs aren't sensitive to noise on USB bus. If you had such noise, then this would improve it. My classic answer to that is, why would you buy a DAC that has such dependence on noise on USB? But I happen to have one DAC that I know for sure from testing before that is very sensitive to the quality of the USB signal. It's an ancient DAC from Shed, the company, called Modi 2. The company builds state-of-the-art products today. But at the time, they had built this Modi 2, they weren't where they are today. And if you look in here, you see the SINAD now, drops way down to 73. So we're way down. You can see why the noise floor is quite high in here, and we have a series of distortion spikes in here. And it only puts out 1.6 volts or so instead of 2 volts that the other ones did. So we go ahead and plug in JitterBug. Surely it cleans up the noise on this guy. Well, no. Even though we have much more elevated noise, we have a DAC that's sensitive, and the SINAD didn't change. Interestingly enough, the output of this DAC dropped 0.01 volts. Not a whole lot, but it dropped 0.01 volts, which tells me that the JitterBug is causing enough extra impedance on the power line to cause the output of this DAC to drop a little bit. So it's actually doing some wrong, doing some harm in here, rather than doing some good. So no noise been reduced, nothing, but you actually lose a little bit of output that you don't want to lose. Jitter test is very sensitive, and if you, for this DAC, and you can see when I run it, what an awful display you get now. This is called broadband random jitter. So it widens the skirt, as we call it, around our main 12 kilohertz tone. This is the only wanted signal in here. This is all unwanted. And again, we connect JitterBug to it. It makes no difference. And, actually, as I commented, it actually gets a hair worse. Why it gets a hair worse, who knows? But it certainly didn't make it any better. Once again, we also just look at the noise spectrum. And, DACs plugged in, and we go with or without JitterBug. And notice in here that there's just nothing is filtered whatsoever. So objectively, we can't find that it reduces jitter. Objectively, we can't find that it reduces distortion. Objectively, we can't figure out that it's reducing jitter either. Well, we figure out that it's not reducing jitter either. So there's really nothing really has happened. But the claim is that, well, the ear is more sensitive, we're not measuring the right things. Never mind the company's claims, we did measure. But doesn't sound any different. So I took this MODI DAC that is most sensitive to power line artifacts and hooked it up to this SMSL THX SP200, which is a state-of-the-art headphone amplifier based on THX technology. So it's as transparent as you could possibly get. And I used my Sennheiser HD650 as a headphone. And then I drove the MODI 2 direct, excuse me, or through JitterBug. And I played my best reference tracks with tons of detail and everything. And the nice thing about Roon was that it was able to recover when I unplugged and plugged back things in about 5 seconds, able to just continue playing. And I heard no difference whatsoever. Now I realize there are a lot of people who buy these things. If you look at the reviews in here, there are 761 reviews, 4 stars on the average. So a bunch of people think they're hearing a difference. And I've explained the reason for that before, because essentially when you change something in your system, you pay more attention and you listen more carefully. And then you say, wow, look at this, sounds better, sounds more fluid, there's less noise. But that's all the fidelity that was in your source to begin with. And when you take it out, you're going to program yourself into thinking, okay, this was the reason it was all improved. You plug it in direct and all of a sudden, oh yeah, without it sounds dull. No, it doesn't. Have a loved one do the test that I did behind your back so you can't tell. And do it 10 times, see if 8 out of 10 times you can tell when JitterBug is plugged in or when it's not plugged in. And I guarantee you that you will not be able to pass that test whatsoever. You'll be lucky 4 or 5 times you get it right. And if you get it 4 or 5 times, then it's basically randomly guessing. So all the obvious improvements that you heard, and if it's that obvious, you should be able to get 10 out of 10. You're not going to get 10 out of 10, or remotely so. Or these guys would sell millions of these things on this thing. Now, sometimes I do teardowns on these, but these come kind of glued together. So, but luckily I have a Samoyed dog that found this JitterBug that I owned and managed to chew it up and do a teardown for me. Remarkably, the unit worked perfectly. Nothing was damaged despite the case, and you can see some of his white hairs stuck to this. And so we now, courtesy of our dog, you get to see what's in it, and I think I'll have a zoomed up picture of it in here. If you look in here, all you're seeing, the L means an inductor and C means a capacitor. So basically, this is just a low-pass filter that's put in around data and or power line. And that's fine and dandy, but there's a problem with cleaning up the data lines. The USB bus is running pretty high speed, so these pulses are coming. You can't filter that, because if you filter those pulses, the pulses get rounder and they actually cause problems being able to extract that data correctly. So filtering is not your friend necessarily. Now, you could filter frequencies that are way above what the digital receiver wants, and in that case, a good thing. But boy, you're filtering very, very high frequency RF that doesn't make it into the device anyway. And power line filtering, yeah, you could. You know, that's DC, so the 5 volt that's on USB bus, you could filter that. But the question for you is this. Why do you think somebody designing a DAC that knows full well is going to be hooked up to a PC that's noisy PC wouldn't put these 3 cents worth of parts inside your DAC. Think about it. What is that designer that stupid that didn't know that this is all you had to do? Put this little few parts in there, and bam, jitter goes down. Sound is no longer flat. It's not irritating anymore. This is all it took. A couple of inductors and capacitors. Don't you think these capacitors and inductors are already inside your DAC? The DAC never runs off of that 5-volt input that comes in. It takes that 5-volt input, it's only positive. The DAC many times needs both positive and negative. So it regenerates the negative using a switching power supply usually. Well, always if it needs it. And even the positive, they don't want 5-volt. It usually runs at 3.3 volts or maybe even higher voltage for the output stage. So the 5-volt is like a raw input that comes into the DAC. The DAC regenerates it into a DC and then filters that DC. So what it gets is extremely filtered. That's what the good DACs that I test them on this noisy gaming style workstation I have, and I've tested it on other computers that I've had. All high-performance DACs generate the same noise, same distortion as I've shown you, and it absolutely does not make a difference. Why? Because any designer knows what they're doing, builds a proper DAC knowing that the USB bus signal is noisy and you got to filter it. And if you could use a charger, the dongle, that dongle is also not going to be the cleanest power. So all of this technology is already in there. Why spend $69 on this? You could buy a whole DAC that doesn't have any USB dependency for 69 bucks. Why would you go spend money on something like this? So just know that there's no magic in it. There's nothing really in here. You're paying for manufacturing of this thing, packaging it, shipping it to you. Amazon takes their cut. AudioQuest takes their cut. Whoever made this takes their cut. So, and I don't want to just go after AudioQuest. I've tested the other ones. So one other one is this IFI, this micro iUSB 3.0. This one's quite expensive. It's $400. And somebody sent this to me for testing. And same story, I won't bore you, although before I get there, there's something on their website, I think, when I looked at it, says, this is, who's it for? It says for systems that are more than $1,500. Kind of a snobbish statement that if your system's too cheap, this is not good for you. But anyway, I do have expensive system. I've used it on it. It makes no difference. Anyway, I won't bore you with all the measurements, but here we have much better DACs to test with because time's gone by and it's a much newer review. You can see that I got 118 dB SINAD of topping D90. And if I use it with iUSB, it makes no difference. But it's got a little switch where you can float the ground. That can be useful, actually, because you can get ground loops. But when you flip that up, where you're floating the USB bus, you actually generate new error that didn't exist at 18 kilohertz. And you can see that in here, or 16 kilohertz. So don't go floating the ground thinking that it always does some good. It doesn't necessarily do any good. So, these companies, I'm sure, will be up in arms seeing this write-up. And my answer to them is what I put in here. If you think it's any better than this, show me the measurements. Or show me a blind listening test. Don't say we've sold 100,000 of these things. It doesn't matter. You can sell anything to anybody on this thing. Just make some claims and make people believe the claims and they go plug it in. And as I explained, it's just human nature when you go buy something new and plug it in and you're going to want it to sound better, and it will. Or even if you don't think it's going to sound better, you can still fall prey to what I explained as far as your mind changing and looking at these things. So please don't spend your money on these things. If there's a new one, and by the way, I've tested other ones that I'm not going over. If you go to audiosciencereview.com and search for these things, you'll see that I've tested others. And it's just the same story repeats over and over again. If there's a new one and you think their claims are valid, you're in the US, send it to me. I'll run these tests. I'll listen to them, and we'll get that data. But for now, based on years of testing these things, and the fact that the whole concept of what they do is faulty, they absolutely, positively do not do anything useful. They don't do it useful. They don't do it electrically. They don't do it by measurements, and they don't do it for your ear either. So don't fall prey to, we don't measure the right things. well, I've listened, and I've listened properly, and it absolutely makes no difference. Okay, thanks for stopping by, and hope you enjoyed this debunking review or article or video, and see you in the next one. Bye-bye.